we've now discussed what a chemical reaction is, and one of the most important aspects in determining a lot of chemical properties and interpreting observations is balancing chemical reactions. So I'm going to put together a couple tips in this video to help you balance these chemical reactions and to kind of come up with a scheme in order to do so. So tip number one would be that if a reaction has unbalanced atoms other than hydrogen and oxygen, first balance them, then balance the hydrogen and oxygen. So for example, if we had C3H8 as a gas plus O2 as a gas, giving CO2 as a gas plus water, also in the gaseous state, we want to first balance all the other species, then come back and do the hydrogen and oxygen. So in this case, we have 3 carbons on the left and only 1 over on the right. So we're going to put a 3 in front of the CO2. That balances out the carbons. Now we want to figure out how to balance the water over here on the right hand side. So if we have 8 hydrogens on the left and only 2 on the right, we need to put a 4 in front of the water. If we now look over on the right hand side, there's 6 plus 4 or 10 total oxygen atoms. So we need to put a 5 in front of the O2, and this is going to balance out that particular reaction. Okay? The second step, and you can kind of, this kind of goes in order, we're kind of going to be all over the place here a little bit. So the second tip is we want to balance polyatomic ions, and remember they're the ones you needed to memorize from the tables in the text, as single entities if they appear on both sides of the equation. So if we have PO4, we want to make sure that you consider that a single entity, because the phosphorus and the oxygen are not coming apart. They're going to stay together as that ion. So for example, if we have CaCl2 plus H3PO4, giving us Ca3PO4 twice plus HCl, we want to consider each of these polyatomic ions as a single entity. So if we look here, one of the first things we could do is balance the calciums. So we have 3 calciums on the right, only 1 on the left. So we're going to put a 3 in front of that CaCl2. That will give us 6 chlorines on the left. We only have 1 on the right, so we're going to put a 6 in front of that HCl. This gives us 6 hydrogens on the right, 3 hydrogens on the left. We can put a 2 in front of that PO4, or H3PO4, which then will allow us to balance that chemical equation. And note that we don't consider the phosphorus and the oxygen separately in the phosphate group, because that is a polyatomic ion that's going to be very stable, and it's going to, stay together and not break apart. Okay? The third tip is going to be to begin with unbalanced atoms having a charge greater than 1. So for example, if we have K2S plus AlCl3 giving Al2S3 plus KCl, the first thing we're going to look into balancing is the one with the largest charge, which in this case would be aluminum. On the right hand side we have 2 aluminums, on the left we only have 1. So we want to put a 2 in front of the AlCl3. The second thing we can look at is the sulfur. Here we have K2S, and over on the right we have Al2S3. So you have 3 sulfurs on the right, 1 on the left, so we're going to put a 3 in front of the K2S. This gives us 3 sulfurs, 2 aluminums, so everything is balanced with that first complex on the right. The KCl, we now have 3 times 2 or 6 potassiums and 2 times 3 or 6 chlorines. So we need to put a 6 in front of the KCl. So that will allow us to kind of double check to make sure that we have the right number of atoms on each side of this particular equation. The next tip that I'm going to give is that if there are an even number of atoms on one side and an odd number of atoms on the other, begin by multiplying the odds by 2. So for example, if we have nitrogen, which is a diatomic gas, plus hydrogen, which is also a diatomic gas, giving NH3, in this case we have an odd number over on the right hand side. So with the number of hydrogens. So let's multiply the odd number by 2. That gives 2 nitrogens and now 6 hydrogens. We already have 2 nitrogens on the left. Now we're going to put a 3 in front of that hydrogen also to give 6, which 2 times 3, we have 6 hydrogens also on the product side. So if you're kind of stuck and you're not knowing what to do and you have an odd number, just multiply it by 2 and see how that works out, and it'll help balance things out. Last step, always check your work. If you can count properly, you're going to know if you're correct, because the number of atoms on the left-hand side has to equal the number of atoms over on the right-hand side.